Okay, students, now we are going to study the next topic of the coordinate compounds and most important, most useful and difficult to understand. Okay, so this involves your practice. The more you practice and the more you intervene, then better will be the result. Okay, so it should be like interactive session. If I only teach whether you are able to understand or not, then there is no use. Okay, so that's why I will be involving yourself. I will be giving some time for you to practice and try yourself. Then I will be trying to explain. Okay, and some topics are there which are discussed afterwards, but without them, this understanding this topic is difficult. So that topic also I will introduce in the initial, then I will be continuing further. Okay, so let's start one by one. Here, structure and hybridization. Okay, so first of all, these are the possible number of hybridization. Okay, so these are the coordination number. Okay, so first of all, you should know the coordination number that already we have discussed. Anyhow, I am going to write over here. Coordination number is simply number of ligands. How many ligands are there? Number of ligands and into their denticity. Okay, into their denticity. How much is the denticity and ligands? So what are ligands? The any substance, any molecule, any ion which can donate lone pair are called as a ligand. And how many lone pair they can donate, that is called as a denticity. Denticity is defined for ligands. Okay, so based upon the ligand denticity only, they are divided into monodentate or unidentate. Okay. Then bidentate or didentate. Then tridentate, then tetradentate, then polydentate, then flexidentate and ambidentate. These are the five types. Okay. First of all, monodentate or unidentate. Second one, it is called as a bidentate or didentate. Next one tridentate. Next one polydentate. Okay. Next one it is called as a flexidentate. Okay. So flexidentate means its denticity is not fixed. It can change according to the substance to which it is donating. Okay. So it is ready to donate 6 lone pair, but the central metal ion is requiring only 4 lone pair. Then that is called as a, it can change its denticity up to the 4. So that's why it is called as a flexible. Okay, denticity can change according to the requirement of the central metal ion. They are called as a flexidentate. Next, ambidentate. Ambidentate means the denticity, whose denticity is 2, but it will act as a monodentate, which got the capacity of bidentate but act as a monodentate. They are called as a ambidentate ligand. Okay. Suppose if you take the carbon monoxide, okay, so lone pair will be available on carbon and this can donate in this direction. Okay, so same if you take the Cn minus, okay, nitrogen can also donate, carbon can also donate. So but at a time it will donate only either carbon or nitrogen. Okay, such substances which have the two donor site but only one will donate at a time, such ligands are called as a ambidentate ligands. Okay, like NO2. In NO2, nitrogen can also donate and one of the oxygen can also donate. But at a time, only one will donate. Okay. So that is called as a denticity. Okay. So depending on denticity, then what it is classified, they are divided into monodentate or bidentate, then tridentate, tetradentate, flexidentate, then ambidentate. Okay, and there is one more special type of ligand which is called as a bridge ligand. Okay, what it is called as bridge ligand. So bridge ligand is just opposite to the ambidentate ligand. Actually, they have only one donor site. Let us take OH minus. Okay, donor site is one, but it can donate two lone pair to the two central metal ions. Okay, if only one metal is approaching, then it will be unidentate. If two metals are approaching, then it will be bidentate. such ligands which can change its density depending on the number of metal ions. They are called as a bridge ligands. Okay. What is the difference between monodentate? Sorry, there is a small difference between these three options. Okay, ambidentate and bridge ligand and flexidentate ligand. These are the three things which are completely appearing to be very same, but there is a minute difference. What is the ambidentate ligand? It is a bidentate but act as a monodentate. Okay, it is a monodentate but act as a bidentate. Okay, only one donor site is there. And flexidentate, it has the capacity to change, switch over between monodentate, bidentate, hexadentate, tetradentate. They are called as a flexidentate ligand. Okay, flexidentate ligand is EDTA, ethylene diamine tetraacetate. It is a EDTA, and you have to be very careful. In the market, there are very wrong things also they are selling by writing it as a TA. Okay, so EDTA, small ta means triacetate, capital Ta means tetraacetate. Okay, so before purchasing, before getting them, you should make sure that it should be 4 negative. If they are 4 negative, then only it is sure that it is tetradentate and sorry, tetraacetate. Okay, so this is about the denticity. Okay, so this was already discussed. If you are not gone through that, the you can go through it. Okay, you have sufficient time. Okay, now the only thing you have to have the interest to study. Okay, there is no limitations for study. Lot of things are already available, but if you want that, you wanted to study and explore the good career options, definitely things are already available. Okay, now coming to the coordination number, I think it is clear. Coordination number, here whatever it is written as a cn stands for coordination number. Depending on coordination number only, depending on coordination number only, we will decide the hybridization. Okay, and hybridization will decide the geometry. Hybridization will decide the geometry. Okay, so these are the very rare things: sp, sp2 and sp3d. Okay, these are very rarely they are asked. Okay, but most frequently they are asking is 4 and 6. Okay, 4 and 6. When coordination number is 4, then what are the options? Coordination number is 4, that can be hybridization, can be DSP2, and hybridization can be SP3. Okay, when coordination number is 6, it can be SP3D2, it can be D2SP3. See, shape wise it is same, but if it is SP3D2, then it is called as a outer octahedral. Okay, otherwise it is also called as a high spin octahedral. Okay, high spin octahedron. Understood? So then spin free. These are the three names which are available. Which are available. What are the three things? Outer octahedron, high spin octahedron, or spin free octahedron. Okay. So if you understand the concept behind that, then it will be outer can be replaced by, here what should be the name? Very good. Okay, it should be inner octahedron. Okay, and high spin should be replaced by, high spin should be replaced by, high spin should be replaced by, very good, low spin octahedron. Okay, low spin octahedron. Spin free you may not be able to guess. It is called as a spin paired. What it is called as? Spin paired octahedron. Okay, spin paired octahedron. Outer high spin spin free, inner low spin or spin paired. Okay, these are the DSP3. Anyhow, we are going to solve the questions related to it. That time it will be more and more easy. Okay, so more convergent with that things. Understood? As I told you, I want the interactive session. Okay, I am not the one which is only I will teach whether people are receiving or not. I am not bothered. It is not my kind of teaching. Okay, so I want that it should reach to the every student of the class, whether he is failure. Only he should have the interest. Okay. Now, as I told you in the initially only, there are some topics which are in the syllabus, but after this topic. But I felt myself difficult to make you understand, make the previous batches understand about this concept without this. Okay. So for easiness, I am teaching well before, but afterwards also we will study. In that topic also we will study in detail. Okay. So what is that spectrochemical series? So it is just like electrochemical series only. It is just like a electromagnetic spectrum only. Okay. Always a series will be arrangement of the things. Okay. Now here the arrangement of spectrochemical series is arrangement of. Okay. Spectrochemical series is arrangement of what it should be, arrangement of dash in dash order, in dash order of CFSC. Okay, what is the CFSC? For time being, leave this. That we will come to know in the crystal field theory. Up to now, with having a glance over this, you should be able to fill these blanks. Okay, so we will say the first blank. If you are if you are keen in the class and attempting the class with the utmost care and interest. Okay. Okay, first trial, but anyhow tried. What are these things? Arrangement of ligands. Okay, arrangement of what? Ligands. Okay, in which order? It is increasing order or decreasing order? Okay, very good. In the increasing order of CFSC. What is the CFSC? For the time being, you leave that. Okay, that will be practically calculated. That CFSC practically calculated, how it affects, that will come to know. But you should know that our ligands are classified into three types. Okay, weak field ligands. What these are? Weak field ligands. Okay, weak field ligands. These are called as a weak field ligands. Okay, these are called as a borderline ligands. What these are called as? Borderline ligands. Okay, borderline ligands. And these are called as a strong field ligands. These are called as a strong field ligands. Okay, strong field ligands, and we can write it as a SFL. Okay, this is called as a BLL. Okay, and this is called as a WFL. In future, if I use WFL, you should understand this is a weak field ligand. Okay, so for time being, for only up to the 12th standard, okay, grade 12, you can take this borderline ligand also, weak field ligand only. After this, these are considered as, after ammonia, these are considered as a strong field ligand. Okay, and there is an exceptionally different behavior by the C2O4. Okay, so these are the strong. For time being, you will remember this strong field ligand, and all of them are together only. Borderline ligands are weak field ligands. Is it understood? So this arrangement is going to help you in understanding and estimating the hybridization. Once you know the hybridization, it is just like a chemical bonding. It will be, structure will be same. Whatever the hybridization there you do, and same thing we are going to do it here also. Understood? So this is about what? Spectrochemical series. Spectrochemical series is basically arrangement of ligands in increasing order of their crystal field splitting energy. Some books it is written as a stabilization energy. Some books it is written as a splitting energy. Okay. Now let us see the what is the next. Okay. Some important points are there. Okay. So these series, actually these points are useful for attending the more than one correct options related to theory. This series has been determined experimentally, okay, and not a postulates of VBT, valency bond theory. Okay, in chemical bonding already we have studied valency bond theory, lone pair, lone pair, lone pair, bond pair. Okay. However, we predict the structure, electronic configuration, magnetic properties of a coordination complex. Okay. Then ligands given in borderline criteria act as a both strong field and weak field ligand. By knowing the values of magnetic moment, it can act as a strong field or weak field. Actually, borderline, that can be sometimes they will act as a strong field, sometimes they will act as a weak field. Okay, so like once you come out from the examination and your parents or friends will ask, what about your BTech seat, or what about your future? They will say it is in borderline. 35 marks is the passing marks, and I have attempted 37. If one or two are wrong, then I will be failure. If they are correct, I will be pass. Same thing is borderline here. Okay. So depending on the situation, it will change. It can be strong field, it can be weak field. Okay. Generally, ammonia behaves as a strong field ligand and H2O as a weak field. Okay. That means after ammonia, whichever is higher, they will be strong field. Before ammonia, including water, will be weak field ligand. So this is what I told you, oxalate. Okay. COOX3 minus is one of the few rare example where oxalate ligand act as a strong field ligand. Experimental value, that is CFSC, is lower, but why it is acting as a oxalate, still experiments are on. What factors making it to act as a strong field is not yet known, but delta value, according to delta value, it is borderline ligands. Okay, so but it is mostly acting as a strong field ligand. Okay, so this is about the spectrochemical series. Now I will give you some examples, with some examples, and how to find out. More practice is required. Like all of you, I think, gone through that lecture of the naming. More and more examples you do, more, and less will be the mistakes. Okay. First question, if you make five mistakes, then slowly it will be four. So slowly it will be three. And every mistake will teach you something. Okay. So the more mistakes you are making, that means more things you are learning. You should take it in that way. Okay. Now let's take the first example, how to find out the hybridization, and everything I am telling you, one or two examples, model examples I will be covering. After that, you can practice on your own. Okay. So here in the central metal ion is nickel. Okay. So nickel atomic number is 28. First of all, you should write the nickel electronic configuration. Okay. Helium, neon, argon. That means 18 electrons already I have written. See, whatever I am doing, that is the difference between studying from the books and attending the video lecture. Okay. So 4s, you should write it here. In the book already it will be printed. How you will come to know? Okay. 4s2, now 20. Then it will be 3d8. Understood? This is the way you have to write. This is the foolproof method adopted by the most of the toppers. I have observed their approach while writing. Okay, so then some students are making mistake because of these habits only. Okay, they are not following this habit. Obviously, they will be making something wrong. Okay, now you have to find out the oxidation number. Okay, so oxidation number already you have studied in the class 11th. Okay, first year. Then nickel plus 4 into chlorine is equal to -2. Whatever the charge given here, that is -2. Okay. So nickel plus 4 into -1 is equal to -2. Then you will get nickel as a +2. Okay. So oxidation number of nickel is +2. Is it understood? Now I have to write the electronic configuration of nickel +2. Okay. Now here argon. See, if I write it here, Bohr-Bury rule says that you should fill up first, but it does not says that you should write outer. Okay. So I will remove two electrons from here. Then this is the valency shell. Always electron must be removed from the valency shell. Okay. So this is one or two students currently also don't have this concept. Electrons are removed from the valency shell, then we will use the penultimate shell. This is the penultimate shell. Then we are left with the 3d8. We are left with what? 3d8. Now according to Hund's rule of maximum multiplicity, electrons are to be singly occupied. Then pairing is done. Okay, then pairing is done, 3d8. Okay, now it will be 4s0, then it will be 4p0. Is it understood? And now we are studying not covalent bond, we are studying the coordinate covalent bond. The difference between covalent bond and coordinate covalent bond lies in hybridization of orbital. In covalent bond, we hybridize half filled orbital. Okay. So if electron is there, then only we will hybridize for the covalent bond. But in coordinate covalent bond, we will hybridize only empty orbital, we will hybridize. Okay. So here oxidation number is +2 and coordination number also we should find out 4 into chlorine. Okay. And there is a minute difference between the coordination number and oxidation number. Oxidation number comes with the sign plus or minus you have to write. Okay. But here chlorine donates one lone pair. This is density. So coordination number is how much? 4. So coordination number is 4. So I have to count like this. 1, 2, 3, 4. These are not electrons. For counting, I have put the dot. Okay. So 4 electrons. Now hybridization will be sp3 hybridization. Okay, what will be the hybridization? sp3 hybridization. After that, we will check here. So, two unpaired electrons are there. So, at least one unpaired electron also present. What does it mean? That is a paramagnetic. At least one also there, it will be paramagnetic. Okay. So, now I am drawing the structure of the nickel tetrachloride. Okay. Nickel tetrachloride. But as per IUPAC name, it will be tetrachloronickelate ion. Okay. Recently, we have studied this naming also. In the square bracket, we should write the name of the ligand first. Okay, tetrachlorido. Okay, tetrachlorido, as it is negative ion. Okay, it will be nickelate. Okay, nickelate, as ion negative charge is there, therefore it will be ion. Okay, tetrachlorido nickelate ion. Is it understood? Now, this is the sp3 hybridization paramagnetic. Now I am drawing. Okay, as it is the digital board, there are lot of advantages. Okay, lot of things we cannot do it on the black board or green board. Okay, so nickel will be here, and here I am using the other color like green color. Okay, so Cl minus and Cl minus. Okay, Cl minus and Cl minus and Cl minus. Okay. Now I forgot to write here nickel +2. Okay. So here this will be coordinate covalent bond. I am representing the coordinate covalent bond with the blue arrow. Okay. So this is a lone pair donated by the Cl minus into the empty orbitals of nickel. Okay. Now if I join them, what I am going to join? I am going to join the chlorine. See, this is the chlorine. Okay. This is another chlorine. And this is the another chlorine. Okay. This pink color line, sorry, purple line represent the tetrahedral. What is this? This represents tetrahedral. Okay. So this is what the nickel tetrachloride. Structure of nickel tetrachloride, I think it is clear to all of you. Okay. So this is about how to find out. Lot of things we could find out here. First of all, coordination number 4, oxidation number -2, paramagnetic. By using this, you can find out the magnetic moment, structure, hybridization. These many things you have to. Okay, after the NaCl4 minus, now our next example is of the NaCO4. Okay, next example is of what? NaCO4. Here central metal atom is same. Okay, but everything, almost everything is different. Okay, that's why deliberately I have taken these examples. You should know the difference when ligand changes. There are two things changes about the structure, type of ligand and charge on the ligand, both are effective. Okay, so same nickel and with the same nickel with atomic number 28. So helium, neon, argon. Okay, then 4s2 and 3d8. Okay, 3d8. So here again oxidation number first you have to find out. Okay, so nickel plus 4 into CO, nickel plus 4 into CO will be 0 because total charge is given how much it has is 0. So nickel plus 4 into carbon monoxide is a molecule. Therefore, its oxidation number is 0. Oxidation number is what? 0. So nickel oxidation number is how much? 0. So that means you need not to eliminate any electron. Oxidation number is about you should not eliminate any type of electron. Now let us find about the coordination number. Okay. For coordination number, 4 carbon monoxides are there. Okay. And you are writing the density. 4 into 1 it is equal to 4. So coordination number of the nickel is 4. Oxidation number of nickel is 0. Okay. Now we are going to utilize this. So first of all we should write the electronic configuration, and nickel only it is there, so you need not to write the next electronic configuration, that is ionic configuration. You need not to write. What you need not to write? Ionic configuration you need not to write. Okay. Now let us take the next 3d8 and 4s2. Okay. So now it's time to go back. Okay. Why this carbon monoxide? Okay. Carbon monoxide. You can check here carbon monoxide. That's why I told you it will be useful in understanding. Okay. It will be useful here. Carbon monoxide is the strongest ligand. Okay. Strongest ligand. So once it is a strong field ligand, then there should be one more type of electronic configuration. Okay. So that reason also I am writing, so that in board exam descriptive answer you should be able to write it properly. Okay. So what is that? As carbon monoxide, okay, is a strong field ligand. You will write full form. Okay. Strong field ligand. So electron pairing, electron pairing takes place. Electron pairing takes place against Hund's rule. This same sentence you will write, because the person who is coming for your correction, they will check these words. Okay, against Hund's rule. Okay, what is that meaning? That I am going to tell you now. Hund's rule, against the Hund's rule. So here 3d8, I am writing it here, 3d8 and 4s2. Okay, Hund's rule. So according to Hund's rule, what does it says? Pairing should not be done. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Understood? Now these electrons, this will go to here and this will go here. So this will take place only in presence of strong field ligand. Okay, now new configuration is going to be what? 3d8 will become as once two electrons are transferred here. Now 3d8 will become was what? 3d10, and 4s2 will become as 4s2 will become as 4s2 will become as 3d8 became 3d10. Now 4s2 will become as, very good, 4s0. Okay. So 3d8 and 4s0. Is it understood? This will take place only in presence of, yes, only in presence of strong field ligand. Okay. Now 4s0. Then 4p. 4p is already, it was blank. 4p was already, it was blank. Okay. Now this is the nickel configuration when it is associated with carbon monoxide. Sorry, this was I written on the next page, I think. Okay. Not a problem. I will shift to the next slide. Okay. So nickel in presence of tetracarbonyl. This is the configuration. Is that clear? Now coordination number is 4. So 1, 2, 3, 4. Coordination number is 4. So hybridization will be sp3. What will be the hybridization? Hybridization is sp3. but there is no unpaired electron, therefore it will be diamagnetic. Okay, diamagnetic. Is it understood? Now I am drawing the structure. So first in the center, in the previous example NaCl4, I have written nickel plus 2, but here I will write only nickel. Okay, and there it was associated with Cl minus, but now it is associated with the CO. It is associated with the CO, associated with CO. Okay, so each CO will donate lone pair to the nickel. Lone pair to the nickel. Okay. So when I join all of them, this, okay, all of them, all of them, then again it is going to be which shape? Tetrahedral only. That is going to be which shape? Tetrahedral only. Okay. See, you yourself should ask what are the difference. Difference is in the magnetic nature. That was paramagnetic, but it is now diamagnetic. Okay, and similarity, that is also tetrahedral, this is also tetrahedral. Differences, that was nickel plus 2, here nickel 0, that was Cl minus, this is CO 0. Okay, so this is about the nickel tetracarbonyl. Understood? What is the answer? What is the common name? Nickel tetracarbonyl, but IUPAC name tetracarbonyl nickel in bracket parenthesis 0. Okay, so that is about the nickel tetracarbonyl. I think it is clear now. Now let's see the one more similar example. Okay. See, so many examples are there similar. Okay. Sorry, actually it is misprint. It is NaCN4 minus. Okay. So I am correcting it here. This was correct, not corrected. NiCN4 2 minus. Okay. Here the question is NaCN4 2 minus. Now it is also some way it is different. Okay. So again same nickel. Electronic if you find out the oxidation number first, Ni plus 4 into Cn is equal to minus 2. Charge here it is minus 2. Okay. Nickel plus 4 into Cn charge is minus 1 is equal to minus 2. So nickel charge is how much? Plus 2. What is the nickel charge? It is plus 2. Okay. Now let us see about the nickel and nickel plus 2 configuration. There will be three configurations here. Okay. In first condition, two configuration, what is that? Nickel and nickel plus 2. In second case, two configuration nickel and in presence of strong field. Here there are going to be three configurations. Okay. So let us write 28. Okay. Then helium, neon, argon, then 4s2 and 3d8. Okay. Now I have to write the nickel plus 2 configuration. So 2 electron will be removed from 4s2. Okay. So this is the AR and 3d8 will be as it is and 4s will become as a 0 and 4p is already 0. Okay. Now this is not final. This is not final. Why? Because Cn minus is, who will tell? Cn minus is, Cn minus is, it's okay. Cn minus is what I will show you. Okay, I don't tell you, I will show you. See, where is the Cn minus? You can cross check and tell me where is the Cn minus. Yes. Okay, so Cn minus is in the list of the strong field ligand. Okay, so whenever it is in the strong field ligand, whenever it is in the strong field ligand, then what we should do? That wording I have told you now, just now. Whenever there is a strong field ligand, what we should do? Yes, pairing against Hunt's rule. Okay, pairing against the Hunt's rule you have to do. Okay, so pairing against the Hunt's rule you have to do. Okay, so this pairing is possible or not? Yes, pairing is possible. This will go here. Okay, Now 3D8 is going to be 3D8 only. But what is the change now? 3D8 is going to be 3D8 only. Okay. But the change is all electrons are now getting paired. Okay. Then 4s0 is 4s0 only. 4p0 is 4p0 only. There is no change in the configuration of S and P. But hybridization is going to be changed. What will be the hybridization? For finding out the hybridization, what we should find out? What we should find out for hybridization? Very good. Coordination number. Okay. So coordination number here 4 into 1. Cn density is 1, therefore 4. Okay. What is the answer? 4. So 4 orbital. We should start counting from here itself. Okay. 1, 2, 3, 4. So hybridization is going to be what? DsP2. What is the hybridization? DsP2. What is the magnetic nature? What is the magnetic nature? What is the magnetic nature? Very good. Diamagnetic. Okay. Is it clear to all of you? Okay. Now it's time to consolidate our study. Understood? We have seen three things. What are the three things? NaCl4 2 minus, NaCO4 and NaCN4 2 minus. Okay. Now let us write about the hybridization. Okay, let us write about the hybridization. What was the hybridization? Here it is sp3. Here also it was sp3, but here it is dsp2. Okay. Now next, what is the change? Magnetic nature. What is the change? Magnetic nature. Okay. This was paramagnetic. Okay. This was diamagnetic. Diamagnetic or not? This is diamagnetic. Okay. This is what? Diamagnetic. Which is diamagnetic, which is paramagnetic, you can cross check. Okay. Now the question will be more than one correct answer. Both are similar in structure. Okay. Both are similar in magnetic nature. Understood? So these are the similarities and differences between the NaCl4 2 negative, NaCO4 CO4 neutral and NaCN4 2 negative. Okay. So this is where we have done the examples of coordination number 4. Coordination number 4, what are the hybridizations possible? sp3 also possible, dsp2 is possible. Okay. So once it is dsp2, it will be square planar. Which planar? Square planar will be the shape. Okay. Shape is the square planar shape, and it is tetrahedral. It is tetrahedral. Up to here, if you got any doubt, you can ask me. Okay. Next question is somewhat different. Okay. Next question is what? Zn NH3 4 2 positive. As I told you in the initial of the lecture, I wanted to this session to be interactive. Okay. So you can try and then I will explain in short. Okay. I hope all of you will solve this. Pause the video and start doing. Okay, here if you try on your own, the hybridization you are going to get will be sp3. Magnetic nature you are going to get is diamagnetic. As it is sp3, it is shape will be tetrahedral. Okay. So I hope you can do this so that we can discuss some more examples, lively examples in the fastest manner. Let's move on to the next example. Here comes the next and most important exceptional example. Okay. So you can try, then I will tell you what is the exception and what is actually. Okay. What you get will not be the what it is. Understood? So let's see. I expect fastest answers. Okay, here if you write the normal electronic configuration, copper it will be CuNH3 2 plus. Okay, copper atomic number is 29, helium, neon, argon, krypton, helium, neon, argon. So I should write here argon. Okay, which gun? Argon. Then it will be 4s2 and 3d9. Okay. So here copper is of the +2. So argon. Then 4s2 electrons will be removed. Then 3d9 and 4s will be 0. Okay. Now the actual thing comes. Okay. What will come? Actual thing comes. Okay. So this is the person because of whom CFT came. Okay. So there are some good persons because of whom the things will be changing a lot. Okay. Like molecular orbital theory is just because of oxygen. Other theories were able to explain everything, but magnetic nature they are not able to explain. Then molecular orbital theory is given. Okay. Arrhenius theory was excellent, but it could not explain about the basic nature of ammonia. Then Bronsted theory came. So valency bond theory, Vesper theory, everything was going fine. Just it was not able to explain this. Okay. Now see here, hybridization have to be what? sp3. Okay, there is no chance, and magnetic nature is paramagnetic. If we consider this is a strong field, even though it should pair, but there is no chance of pairing. So everybody was thinking tetrahedral paramagnetic. But one sudden day, they determined the structure by X-ray diffraction methods. Okay, so that X-ray diffraction method revealed that it is not a tetrahedral. Then it is found that it is square planar. Okay, then you do anything in the valency bond theory, they were not able to explain. Okay, then CFT told, crystal field theory told, this ammonia will provide sufficient energy to jump from here to here. Okay, then hybridization instead of sp3, hybridization it is dsp2. Okay, then they understood acha why, because of this it is square planar. Still it is paramagnetic only, but magnetic nature is same. Structure is changed from sp3 to square planar, that is dsp2, and structure changed from tetrahedral to square planar. Is it clear to all of you? CuNH342 positive, exceptional case. Never forget this person. Okay. Like in ionic equilibrium, ammonia person to be remembered. In chemical bonding, oxygen to be remembered. In coordination compound, CuNH34 to be remembered. Okay. Because of them only new generation, new theory came. Okay. Is it clear to all of you? Now shall we go for the next some more things. Okay. Okay, here next comes the CrNH362 CrNH36. Sorry, it is 3 plus. Okay, here it is wrongly written. It is 3 plus. Okay, CrNH3 3 plus. Now you can try, then I will explain. All the best. So there is some changes here. So let me explain. Coordination number is here. Now I think everybody can do it easily. Coordination number is 6. Oxidation number is 3. Okay. Now let me remove the 3 electrons. 4s1 3d. Okay. Now there was a question. Which of the following will always forms inner octahedron only? Okay. 3d3, 4s0 and 4p also 0. Okay, 3d3 4s0 and 4p also 0. 3d3 4s0 4p also 0. Now coordination number is 6. So I have to pick up how many orbitals? 6 orbital I have to pick up. From here I should start picking up 1 2 3 4 5 6. Okay, so hybridization will be D2sp3. Okay, so chromium there is a speciality. Okay, it always forms inner, otherwise low spin, otherwise spin free, sorry, spin paired. Okay, spin paired octahedron only, because always this will be already available. Understood? So 3d3 4s 3d3 4s0. And what will be the magnetic moment? Number of unpaired are 3. Now is it understood? In this, if you got any doubt, any clarification, you can ask me. Okay, here we are using the inside d orbital. That's why it is called inner octahedron. What it is called as inner octahedron. Why? Because this is the valency shell and we are using the inside whose energy is less. That's why it is called as a low spin inner octahedron. Okay. Now let's move on to the next question. Okay. So everything you have to be very, 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 very fast enough. See, next question is FeCN6 3 minus. Now it's time to pull up your socks and start solving. So here this example I will tell you so that you can understand. Okay. So iron atomic number is 252626. So helium, neon, argon 4s2 3d6. Okay. Now here oxidation number is plus 3. If you find out oxidation number, it will be plus 3. So I should write about the Fe plus 3. Okay. Then here 2 electrons out, here 1 electron will be out. So 3d5, okay, and 4s0, 4p will be 0. In this one, if you have any doubt, you should not have any further doubt now. Okay, so 3d5, 1 2 3 4 5. Okay, this is the best possible chance, but problem is that our Cn is a SFL. Okay, in presence of Cn minus, what it will go, it will go here, it will go here. Okay, so 3d5 will be same 3d5 only, but the configuration will change like this. Anyhow they want this pair, 2 orbital. Okay, now 4s0, 4p0. Is that clear to all of you? 4s0, 4p0. Okay, now this is the hybridization, inner octahedron d2sp3, but still one unpaired electron is there, paramagnetic. What magnetic this one? Paramagnetic. Okay, I think all doubts are clear now. Magnetic nature, hybridization, and structure. Okay, next question is FeCO5. It is the thing if I want all of you should now do it successfully. Okay, now your time starts now. Okay, see here. First of all, you should be concentrating on oxidation number. Oxidation number, when carbon monoxide is only there, it will be 0. And coordination number is equal to 5. Okay, so iron you can write as it is, helium, neon, argon 4s2 3d6. Okay, so there will be, what will be, there will be, what will be, there will be. Okay, and 4s2. So need not to remove any electron because oxidation number is 0. Okay, but in presence of carbon monoxide, pairing will takes place, time and time. Okay, this will be 3d6 is going to be 3d8 now. 3d6 is going to be what now? 3d8. Okay, 1 2 1 2 1 2 and 1 2. So this 4s will be 0 now. Okay, we will be using 4p also 0 now. Okay, 4s 0, 4p 0. Now we should count 5 because coordination number is 5. 1 2 3 4 5. Okay, hybridization will be dsp3. Okay, now once it is dsp3, it will be triangular bipyramidal. What bipyramidal? Triangular bipyramidal. FeCO, CO, 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 and CO. Okay, these are all will be the coordinate covalent bonds. Is that clear to all of you now? Magnetic nature, for the magnetic nature, it will be diamagnetic. Which magnetic? Diamagnetic. Okay. So now all type of hybridization we are able to cover in a short span of time just because of all your efforts. Okay. Thank you for watching. All the best from Chem. See you. Bye bye. Keep watching, keep rocking, score high.